Hello, I'm Velia Cardin. I'm a neuroscientist, as well as an associate professor at DCAL, the Deafness, Cognition and Language Research Centre. I study the brain, how the brain works, and how it adapts to new things. I'm going to tell you about work that a colleague and I did in 2013. That work looked at how the brain adapts to cochlear implantation and how this links to speech understanding. Why is it important to look at the brain? I'll explain. The brain has lots of different areas. Each area does a different job. One area is responsible for language, another area for vision, another for memory. One of the areas works with sound, and it's called the auditory cortex. In a hearing person's brain, the auditory cortex works with sound. In the deaf brain, the auditory cortex doesn't have auditory input. It's activated by visual input and by touch. So there are differences between the hearing and deaf brain. That difference is called plasticity. How is this difference related to language and speech understanding? I'll explain. Some researchers have thought that perhaps visual language, for example sign or speech reading, would interfere with speech understanding. What were the reasons for this? Maybe they thought that by having visual language added into the activation in the cortex, as well as visual information, would reduce sound activation. Maybe they thought that there would be reduced sound activation and reduced understanding of speech. My colleagues and I didn't agree with this. We didn't think this would be true. There was no evidence for it. And we knew that sign language helps with understanding speech. So, we reviewed all of the literature researching this topic around speech, cochlear implantation, and brain plasticity. What did we find? Firstly, that sign language doesn't interfere, but sign language positively facilitates language development. Secondly, plasticity happens for both oral and signing deaf people. And that's a positive. The changes in the auditory cortex are a positive and just fine. The problem is actually language deprivation. What does this mean? I'll explain. For a deaf baby with access to a visual language, sign language, the baby can receive just fine and develop language well. But sometimes for deaf babies, they don't have access to a visual language. If they don't have that input and they don't develop an understanding of language, and they miss out on having a language, that's language deprivation. For a baby without a language who is deprived of any language, this can be problematic in terms of understanding speech. And this is regardless of that visual language being signed or spoken. So what is the problem here? Language deprivation is often mixed up in the research with visual language. So to give an example, usually the researchers want to look at children who have cochlear implants and their understanding of speech. Well, there are different children with different language abilities. Typically, they're put in one of two groups. One group, all oral children who understand speech well. In the other group, all of the children actually have varying abilities. Some of them will be fluent native signers. In the same group, there will be others who may not use sign language well, yet they're all combined into the same single group. Some of them will be language deprived. Measuring speech understanding between the two groups and making comparisons, the oral group come out better. But if one more group is made and that group is of fluent signers, making a comparison with the oral group produces the same results or better. Why is this research important? It provides evidence to show that early input is important. It's important whether that's sign or oral. A baby should have early access to a visual language for their development. We wanted to remove any doubts around sign language having a negative impact on the auditory cortex or the brain in general. We found that it didn't. There is no evidence to show that. We also wanted to provide evidence to people who may talk about language and communication when talking to parents of a new baby, perhaps doctors or teachers who may be unsure about whether to sign with a cochlear implanted child or focus only on speech. This evidence tells them that signing has no negative impact on the brain, proving that other statements are not true.